rational expressions we do first because it's one that is covered in 20-1 with trinomials and such like that. So if we had someone switch down from 30-1 to 20-1, it won't be, or 30-1 to 30-2 late, it won't be so bad. We also do it because it's one that challenges a lot of people, because it's a lot of algebra and fractions. Rationals are based around fractions, and everyone's fraction rules usually aren't the greatest. Your diploma is 40 questions. You might be like, why are you talking about your diploma? It's the second day. I don't really care. But your diploma is 40 questions. That's it. 28 multiple choice, 12 numeric. Of the 40 questions, 7, sometimes 8, usually 7 are on rationals. 7 of 40. So if you're like someone who leaves this unit, you're like, I really wasn't very good at it, but it's okay. It's not. 7 of the 40 questions are from this unit. Okay? So we really have to pay attention and do well. The more you practice these, the better you get at them. Okay? So, rational expressions. We're going to look at non-permissible values first. Non-permissible values, or NPVs, a lot of people call them MVPs just because I think MVP maybe, but they're NPVs, non-permissible values, and they can also be known as restrictions. There's always a non-permissible value question on your diploma. Always, always, always. That should be your give me question though. It should be the easy one. The non-permissible values are the values that can't exist. They're not permitted to exist. Well, the only reason why we have issues with rationals are when you have like some sort of something over something. It's like a fraction with variables, basically. So if I had x plus 2 over x minus 3, that's a rational expression. Okay? I actually have variables in the numerator or denominator, both. The moment you have a variable in the denominator, so a letter in the denominator, you have restrictions or non-permissible values. Because your denominator can never equal what? 0. So because your denominator can never equal 0, we have to state what x value would cause this denominator to equal 0 and say we can't have it. That's what a non-permissible value is. It's what the x value would be. If we had it, the denominator would be 0, and we can't have a denominator be 0. So every single time you have a variable or a letter in the denominator, you have to state non-permissible values. So for example, with this example here, the non-permissible value would be when x minus 3 equals 0, correct? When x minus 3 equals 0, we can't have that happen because we can't have the denominator equal it. So if we wanted to find the NPVs of this question, I don't care about the x plus 2 because that's not an issue. Even if it was 0 in the numerator, I'm allowed to have a 0. I can go 0 divided by 7, and my calculator will say 0 is the answer. But if I go 7 divided by 0 in my calculator, it'll say error. It won't let you do it. So you can have a 0 in the numerator, but you can't have a 0 in the denominator, the bottom. So what am I going to do? I'm going to take that denominator, x minus 3, and I'm going to say it can't equal 0 because it can't. It's a rule in math. And then I'm just going to solve for the x. So how do I move a minus 3? I add 3. And I'm going to get x can't equal 3. And that's my non-permissible value. X can't equal 3. You can always check your non-permissible value. So take that 3, plug it back in. 3 minus 3 is 0. So we're good, because you can, if I had 3 be one of my answers, then my denominator would be 0 and I would be in trouble. Okay? So the non-permissible values exist where the denominator would be 0 if you used it. So it's a value that can't happen. Does that make sense? Okay. So the steps to find non-permissible values. This one was an easy one because I just had an x minus 3 on the bottom. But what if I had 5x squared minus 5x on the bottom? Well, the very first thing I need to do before I look for the NPVs is I need to factor the denominator. If I can factor it by difference of squares, or I can take out a GCF, I have to do that first, then state my non-permissible values. Okay? Once you've factored it, you set the denominator equal to 0 and solve for the variable. So those are your steps that we're going to look at. Those are the steps that we're going to do. So example 1, consider the rational expression x plus 1 over 5x squared minus 5x. So they want us to determine the non-permissible values. Well, if I did what I did in the last one I went and I just took what the denominator was, 5x squared minus 5x, and I said not equal to 0. What am I going to do to get x, though? Am I going to add the 5x over? Now I have a squared and an x? That's a problem. If when you go to do the non-permissible value, you take the denominator, set it not equal to 0, and you'd have an x squared and an x on one side, that means go back, try again. You should have taken out a GCF or done a difference of squares before you started trying to do this. So this is not good. So what do we need to do first? We need to factor or GCF that denominator because this is not helpful. We have two x's. I don't know what to do there. So what can I take out of this denominator? Yeah, 5x. So I have currently right now in my denominator 5x squared minus 5x. Ryan said I can take out a 5x. He is completely correct. And I take a 5x out of 5x squared. I'm left with an x. Then I have a minus sign. 5x divided by 5x, you guys all know this. What do you get? 1, not 0. You get 1. Now, the way to foolproof these questions is if something is attached by a plus or minus sign, it's in its own brackets. If it's attached by multiplication signs, they're in their own brackets. Okay? So the x minus 1 is in a bracket together because it's attached by minus sign. Now the 5 and the x are in their own brackets because they're attached by multiplication. So this 5 is going to be in its own bracket and this x is going to be in its own bracket. If it was 5 plus x or 5 minus x, then they would be attached. Okay? But because it's multiplications, you put them in their own brackets. All right? Now you take everything that's in a bracket and you set it not equal to 0 and solve. So to get my non-permissible value. So I'm going to find out. So 5 can't equal 0. That's true. Does that give me an NPV though? No. Only variables get me non-permissible values. 5 can't be 0. It's true. It never will be 0. It's not going to be an issue for us. So we actually don't have to state it when it's a number without a variable. Okay? Then we do the next one. X can't equal 0. That one's solved already. Sweet. Done. And then we do the third one. X minus 1 can't equal 0. Add 1 to both sides because we're just trying to solve for x, right? And right now we're subtracting 1, so we have to add 1 to get to the other side. And we get x can't equal 1. And then we state our non-permissible values. X can't equal 0, 1. You can put them together. Now, I told you that you can check these and see if you're correct. If when you plug them each in separately, you would get a denominator of 0, you're right. Okay? So I'm going to try this. I'm going to try the 0. 5 times 0 squared is 0. Minus 5 times 0 is 0. 0 minus 0 is 0. So yes, 0 is a non-permissible value. If I plugged in 0, I would get 0 in the denominator, so it's not permitted to happen. Okay? Try the 1. 5 times 1 squared is 5. Minus 5 times 1 is 5. 5 minus 5 is 0. So 1 is not permitted as well because it would get me a 0 in the denominator, and that is one big old rule in math that you would get a ticket if you did it. It's like speeding. Bad. Okay? B is not a trick question. B is really easy to answer if you've answered A. State the restrictions on the variable. They're the exact same thing. X can't equal 0 or 1. My point of doing this in the notes is that restrictions and non-permissible values are actually what? The exact same thing. Just two words meaning the same thing. And they can ask it either way. Okay? Example 2. Determine the non-permissible values, the restrictions, for each of the following expressions. So question A. 3a minus 1 divided by a minus 1. So we ask ourselves, can we take a GCF for a difference of squares out of the denominator? It's a minus 1. No. So if we can't do that, then the second thing I told you to do is bracket anything that is connected with plus or minus signs. And if it's connected with multiplications, we put them in their own brackets, right? So we have an a minus 1 in the denominator by itself in brackets. Once we've put brackets around everything that's separate, we take those separate things and we set them not equal to 0. So the NPVs for this question, we're going to go a minus 1. This bracket's supposed to be only around the denominator. My computer bumped it up, sorry. A minus 1 can't equal 0. And then we just solve for a. How do we move a subtraction of 1? Add 1. So we get a can't equal 1. And we're done. And we check it. Fill in a 1. 1 minus 1 is 0. So we know we're right. I can walk away from that test question knowing I got completely correct. B, 4 divided by 2k squared minus k. What's the very first thing I'm going to have to do? Look at my denominator and say GCF or difference of squares. Nope. Yes. It's a GCF. What can I take out? K. So in the denominator, I'm going to have k outside. 2k squared divided by a k is 2k. Minus k divided by k is 1. So once I do a GCF or difference of squares, my next step is to bracket anything that's attached by plus or minus signs, anything that's not in its own brackets. So this has to be attached because it has that minus sign between them, and this k is going to be in its own brackets. Then anything that is in a bracket, I set not equal to 0 and solve. Okay? So NPVs. K can't equal 0. And I'm done because I solved for k already. And then the other one is going to be 2k minus 1 can't equal 0. Remember, you have to do reverse BEDMAS when solving, so I have to move the subtraction of 1 first. How do I move a subtraction of 1? Add 1. So I get 2k can't equal 1. How do I get rid of the multiplication of 2 by the k? Divide it. So k can't equal a half. And then I go up here and state them together. So k can't equal 0 or a half. If it equaled either of those values, when I plug those in, I'd get 0 in the denominator, which is a problem. Okay? You guys are going to try C and D. Whoops. C and D. Okay. So for C, I have m minus 5 divided by 2m plus 10. I actually don't care about the m minus 5 at this point if they only ask me for NPVs, right? Which is what these questions are. So I'm going to go to my denominator. If I forget to take the 2 out, this one will actually work. If you forget to take the GCF of 2 out anyways, just because this one doesn't have, the 10 doesn't contain another variable. But I'm going to take the 2 out anyways. So I'm going to get 2 and then m plus 5. So the m plus 5 is attached by plus signs, so they're in its own brackets, and the 2 is in its own brackets. So if I want to do the NPVs, I'm going to say 2 can't equal 0 because it's in a bracket, which is true, but it doesn't have a variable, so I don't get a non-permissible value out of it actually. Please don't tell me that x can't equal 2 or something because this 2 is here. Don't do that. If it's just a number, this number will never ever turn to 0, so don't worry about it. It's only when it has a variable, okay? And then we go m plus 5 can't equal 0. Then we move an addition of 5, subtract 5. That's you. And you get m can't equal negative 5. And that's the only non-permissible value. What do we have to spot with D? Difference of squares. What do we get on the bottom? X minus 7, x plus 7. So when we FOIL this out, or when we factor this out, sorry, we're going to get an x at the front because the square root of x squared is x. We're going to get a 7 at the back because the square root of 49 is 7. and then minus plus, or you could do plus minus. It doesn't matter as long as they're opposite signs. Now you have two things in brackets with variables, so we're going to get two non-permissible values. So my NPVs are going to be x minus 7 can't equal 0, and x plus 7 can't equal 0. I'm going to add 7 to this one to get rid of the minus 7. So x can't equal 7. And then I'm going to subtract 7. So x can't equal negative 7. So I can put those together, which they would on the diploma. They'll say x can't equal plus or minus 7. They just write the plus or minus sign in front. If it was written and you wrote x can't equal 7 and negative 7 just separately, that's fine. There's nothing wrong with that. I only just want to show you this just in case they give you this on the test or on the diploma, that you know that that just means both of them, right? You're not incorrect if you don't write it that way. Years, your turn. Try these ones out. Okay, so the first one, we could take a negative 2 out. And you're left with x plus 2. Because when you take a negative out of a negative, you get a positive. So your NPV would be negative 2 can't equal 0, which actually doesn't get us an NPV, so it's just out. And then x plus 2 can't equal 0. Subtract 2. And x can't equal negative 2. This is my only NPV. With B, a squared minus 81 is the difference of squares. So you get square root of a squared, which is a in the front. Square root of 81 is 9 in the back. And then a plus and a minus. And then you'll have a plus 9 can't equal 0, and a minus 9 can't equal 0. Subtract the 9. A can't equal negative 9. And to get rid of the negative 9, you add 9. A can't equal 9. So you get a can't equal plus or minus 9. With C, you have to take out a p. So when I take the p out, 4p squared divided by p is 4p minus sign. P divided by p is 1. Now I have this p, and it's not attached to anything, so I'm going to put its own brackets. And the 4p minus 1 are attached with the minus sign, so you have to keep them together. So p can't equal 0 would be my first non-permissible value, and I'm done because it's already solved for p. And then I'd have 4p minus 1 can't equal 0. What's the first thing I have to move? Yeah. How do I move the 1? Just add 1. So I get 4p can't equal 1. Put your hand up if you know how to get rid of the multiplication of 4. Anyone? Yeah. Just divide it by 4. So we have p can't equal 0 or a quarter. Two x squared plus 8. This one's a bit trickier. I take a 2 out. And then I'm left with x squared plus 4. This is not a difference of squares. The 2 can never be 0. And to be honest, if you have an addition of squares, you're not going to have non-permissible values. Why? Because there's absolutely nothing I can fill into this x that will cancel out a positive 4. If I put a negative, some people say, well, negative 2. Negative 2 squared is what? Positive 4. Remember, if you put in your calculator, you have to put in brackets. Brackets with the negative 2 and square it. Because if you don't put it in brackets, your calculator will always tell you it's negative 4, which is not true. Now I can prove this. So x squared plus 4 can't equal 0. Subtract the 4 over. So x squared can't equal negative 4. And then I square root it. Can I square root a negative number? No. The moment you have that, no NPVs.